Hello, my name is Sam and my marine ecosystem is estuaries. Estuaries are a body of brackish water typically found where freshwater rivers meet the sea. The nutrient-rich and often protected waters mean that estuaries are some of the most productive places on Earth. Estuarine ecosystems provide support for many living organisms. Primary producers such as plankton and bacteria form a fundamental structure for food webs. Estuaries are defined by their unique biotic and abiotic factors. Their biotic features include water depth, salinity, nutrients, air and water temperature, pH, dissolved oxygen, and turbidity. Some biotic features can include shrimp and oysters. This map is where estuaries are located throughout the world. Australia has thousands of estuarine systems. Gross primary production is very high in estuaries because of how many producers there are. Phytoplankton play a very important role in primary production in estuaries. One recent review of scientific literature on 131 estuaries found that the annual median of net primary production was 238 grams of carbon per square metre per year, and the median gross primary production was 393 grams of carbon per metre squared per year. Many factors such as the availability of food, how close the site is to migration pathways, human impacts, and tidal flows can all affect the carrying capacity of a particular estuary. To illustrate this, I'm going to tell you about the Chinook salmon found in western North America. Estuaries provide an important habitat for juveniles of this species. The Puget Sound Chinook was listed as threatened under the Endangered Species Act in 1999, with 70 to 80% of its estuary habitat lost through land development. Fortunately, some estuary restoration projects have been successful in increasing the salmon carrying capacity. The carrying capacity has gone from 38,000 to 360,000 in one estuary alone. The way living organisms interact can be expressed as a food web. Every estuarine ecosystem has its own complex food web, but there are some common principles. It starts at the very bottom with decomposing vegetation, plants, and general plant biomass. Chemical energy is stored in plant biomass via fats and proteins. This is made possible through photosynthesis. These are called primary producers. From there, the energy makes its way up through the trophic levels. Small bacteria and microorganisms such as phytoplankton feed on the vegetation. Phytoplankton plays an integral role in coastal food webs, with primary production almost entirely a function of this microscopic organism. Consumers in the food web include crustaceans, birds, and fish. Apex predators include predatory fish and smaller sharks. Energy transfers occur throughout the food chain. Producers get eaten by consumers, and that energy is then used to carry out complex tasks. The main energy stores in estuarine ecosystems are the sun's energy. Plants undergo photosynthesis and produce chemical energy from the sun's radiant energy. This is then stored as plant biomass. Turbidity is also a very common energy transfer in estuarine ecosystems. This is where freshwater heads seaward and there is an undercurrent of salt water. This creates a salt wedge or a turbulent zone. This turbulence is also a heat transfer, saltier water being cooler and the fresh water being warmer. Having said all that, only 10% of energy is passed on through the food chain via energy transfers. The other 90% is lost in life processes, like movement, feces, heat, and remains that are passed to decomposers. A study in 2020 by Skanes, and Ross investigated the effects of climate change on Australian estuaries. To achieve this, they monitored ecosystems around Australia for 12 years. They surveyed 166 estuaries across 1,100 kilometres of Australia and took over 6,200 observations. Over the 12 years, estuary temperatures increased by 2.16 degrees. They also acidified at a rate of 0.09 pH units a year. Estuaries freshened at a rate of 0.086 PSU a year. The study also highlighted increased carbon across the 12 years. Mudflats started to become less nutrient dense because the carbon content increased. If we're specifically looking at energy in estuarine ecosystems, climate change is paramount. Oceans and estuaries absorb heat, which is a form of energy, from the atmosphere. Increasing temperatures can impact on the biological processes, primary productivity, and alter the photosynthetic matter of submerged plants. As a result of this, the delicate systems could collapse. This study is significant because it gives an insight into the future of our estuarine ecosystems. Scientists were able to quantify what changes may be happening and to assess what our future marine ecosystems may look like. Robust data and education are essential factors for increasingly urgent global fight against climate change. So in summary, what threat does climate change pose to estuaries? Firstly, they'll acidify and warm up. Ocean acidification is where ocean absorbs carbon dioxide, resulting in a lower pH. Clams, mussels, crabs, corals, and other sea life rely heavily on carbonate ions. Carbonate ions become more scarce when marine environments absorb carbon from the atmosphere. Some crucial elements of the food web that rely on carbonate ions will be depleted, in turn impacting on the ecosystem's carrying capacity. Bleaching, caused by a warming planet, also places tremendous stress on estuarine ecosystems. The biggest producer of energy in an ecosystem is photosynthesis. Photosynthetic matter is stored in plant and algae matter. Corals maintain a mutualistic relationship with photosynthetic algae that lives in and around the coral. Without coral, these algae would lack shelter and protection and would result in a significant decrease of energy supply. So what do I think will happen in the next 10 years? Our climate will be more extreme and unpredictable. Carrying capacity will be significantly reduced due to primary producers and energy stores being disadvantaged because of the rising temperatures, acidity, and water levels. Food webs will be minimized to what can survive under the harsh conditions. In 100 years, if climate change continues as scientists predict, without humankind making an immediate and a significant change, there will be no more estuarine ecosystems. Estuaries are a dynamic and a diverse ecosystem with unique and abundant life forms. We must take action in order to keep these estuaries safe around the world. Thank you.